Okay, where is my blue marker? Okay, 1, 2, 3. Okay, today's lesson is lesson number 6. Unit 2 for lesson number 6. Okay, so I'll walk through straight away to the activities. You already have the packet, and you can see the very first question is a warm-up, and it is discuss with the partner why. Of course, you're supposed to discuss, but I'll walk through this straight away. Now, why do you think all these expressions which look different, why are they give you the same answer? That's the question. Now, in order to be successful for this, you have to know a few things, and that I'm going to write quickly here. And which we forget, and the main thing is b raised to 1 over n is nth root of b. See, this is the main how to write two different ways the same thing. Is rational exponents, can you see? And this is radical form. This is rational form. Now, there's one more thing. Is if you have b raised to, so if you have b raised to m over n, so something like, see, m over n, and I use the blue color here, this blue. Okay? This is same as writing b raised to m, and then 1 over n. See? So this is because of power, we forget, laws of exponents. And then this blue, like we can apply the first part, the first piece, and write it as n. So that's the confusion we forget. So I still want to keep this as a flashing what we learned earlier. Then another way to write this is b raised to m over n is the blue part is right here. I will write 1 over n inside. So this b raised to 1 over n, and the black, the numerator I will write up here, and then the inside, the parenthesis is as good as writing n here because of the divide by n. So this will go up here, and then this is b, and this m is out. All this looks very creepy unless you understand it, right? So this part has to be known. Okay? So I'll keep this aside, and when we require, we'll see. So the question is, how do we use that over here? Look at the first one. There's a 3. Remember the 3, the formula here? Let me bring it right here. Got it? I don't know. So the first one is we can write this denominator in the index of the radical. So this is the radical. That's the 3 goes right here. Okay? And then 64 is all it means. Agree? Okay? And then, so what does this stand for? What does this mean? What number multiply itself 3 times to give 64. So what number we need to multiply itself 3 times to get 64? In other words, you are thinking, hey, what is that? What number do I put in this 3 parentheses to get to 64? Is it 1, 1, 1? Or is it 2, 2, 2? Or is it 3, 3, 3? Or is it 4, 4, 4? And quite obvious, so it has to be 4, correct? Make sense? And that's why we say, hey, that. So even I wrote this one. Now the question is, do you have to write on your paper? No, you don't write this. This is in your mind, you're thinking, hey, what is that radical sign means to you? Just asking a question, what number multiply itself 3 times, because there's a 3 here. So multiply itself, you get 64, and then the answer is, you're done. That's all it is. So all you show is little scratch work. So when you turn in the work, sometimes I did that, how I got it. So that's like, 4 times 4 times 4 is 64. So cube root 64 is. Let's go to the next one. So this one, watch this. Whatever the inside the parenthesis 8 square. 8 square means what? 8 times 8. 8 square is 8 times 8, which is 64. See? So simple. So this is 64. And when you write this, it's the same thing here. Watch. Correct? So that means your answer is already, we already did this in the very first A problem. Problem A is 4. So this also is 4. It's the same thing. The 5, right? Then C. What do we do with C? There are two exponents. So laws of exponent we can write this as 2 raised to 3 times and then 2/3. So this is 3 is in the denominator and this one is 3 over 1. See that? So numerator and denominator you can cross it out. And what I left is 2 raised to 2 and 2 raised to 2 is 4. And you're done. So all the values are going to be 4. Agree? Then D. How do we do D here? Now watch this. Inside the parenthesis there is 8 raised to 1 over 3. The blue 3 will come under the radical. You can write this as it. So this piece in the parenthesis can be written as cube root of 8. Then you ask a question. What number multiply itself? So what number multiply itself 3 times to get 8? Okay. What number multiply itself 3 times to get 8? You all know the answer, right? 2? Is it 1, 1, 1 gives you 8? Or 2, 2, 2 gives you 8? So this answer is, so in the parenthesis the answer is 2 because 2 times 2 times 2 is 8. And then this is raised to 2 and you get 4. Correct? The last one is 8, 2 raised. This you can write as what? 8 raised to. I'm breaking this fraction 2/3 as 1/3 inside, okay, and raised to the power. Is that okay? So 2/3. Remember the trick is 2/3. I think 2/3 is 2 times 1. Right? So one of them you keep inside, or you can write 1. I think the one I wrote is 1/3 and 2. So 1/3 and 8 1/3 is 2, which you already worked here. See, this answer is yeah. This answer was 2 and square is. Is that correct? Now, the second question is asking, is there any other possibilities also which can give you, and you can have a lot of options. You see, if I want to get 4, 4 also is square root of 16. Do you agree? Square root of 16 is 4. Because 4 times 4 is 16. You could also write the same piece like this, 2 raised to 2/3 inside and put this 3 outside. That also will give you as 4 also, because you can just cross out this 3 and done. Okay. So that takes care of this activity of understanding this radical part. So we need to, the next activity is about how do we create exponential functions. You see, turn the page, everybody turn the page. Okay, turn the page. Okay, turn the page and can you at least label those whatever uppercase A, B, C, can you put it out the x coordinate and the y coordinate? Okay. I'm gonna only show you the graph part, or the other thing is there on your paper, on your, this is what you have, okay? So what are you expected to do here? Is, first of all, if I want to know how to create an exponential function for this graph, okay? And you can see it is rising, and it's already exponential function, but we need to figure out what. So we need to know why. Let's create exponential function. So to create exponential function, the main function equation is a times b raised to x. So two things we need to know is what is a and what is b. Now to know a is always the initial amount. So we should know, we need to know what is a is the initial value. Oh. Now b, now in the example, if you see the data already shows, can I have it?
You have to write that?
This is, yeah, on the second page. Yeah, so can you see this is the room, enough room to write down there? So this is what you're supposed to do. So each problem, each of these two things that are graph that are there, we need to create exponential function like this. We want to model this data into something expression like this. Because there is a percent increasing there, and we need to know what is the growth factor there. So those are the things. The a is the initial amount, which is 0 is a, like you see. But in the example, you will see there are 4 dots here, and the 4 dots says y-intercept is 200. Okay? What does that mean is, this point is 0 is 200. So this is what I want you to write down on the paper. So in the beginning, it could be, let's see that in a city there was a population of 200,000. That's understanding of, oh, what does this basically, this 200 means maybe in a city there is 200,000 population. Okay, and then maybe these are like decades, 1 decade, 2 decades kind of thing. Some half a year, half a decade, 1 decade, means 5 years, 10 years, 15 years, something like that. We can model that kind of stuff also, but right now it doesn't say nothing what it stands for, we don't know. Okay, so far this is 100. Sorry, this a is 200. Okay. Then we need to figure out what is b. B is the growth rate. So this is called the growth rate. And to know the growth rate, this is for input. So this is for the input x is 0 to 1, or 1 to 2, 2 to 3. No fraction. See this? Of course, you can have fraction, but the input should increase by 1, 1, 1. That's what the b part is. But in the problem, if you see the information provided, the y coordinate of b is 300. See, so that's the second information. So this point is when it is 0.5. This point is 300. See, so this is 300. So that is, what is the factor? By what factor did the number 200 increase to, what multiplies this to get to 300? So the question is, what multiplies? We need to know, see there is a b here, I use b1 because this is b, so 0 to 1 4, sorry 0 to 0.5 for the input, the increment of 0.5, the b1 is, I'm using just like a, to say, hey, 0 to half, what's the growth factor? And you can see this answer is, all you do is, I think many of you forgot what I'm, let me write one more time. From the past knowledge we know, what multiplies 2 to get to 6? In our common sense, gut feeling, by default we know, common sense, we say, hey, it has to be 3. But another way to say this is, imagine you don't know, is you just divide this 6 divided by 2. See? Just get the same thing. 6 divided by 2 is 3. Beautiful. It means you just have to divide the two numbers. So if when you see this number went from 200 to 300, so what multiplies 200 to get to 300? You just have to divide 300 and 200. So simple. And when you do that, 200 divided by, 300, this 2 dividing by 100, this is 3 over 2, which is 1.5. Now this is B1 is 1.5. Now this is only for this B1, the answer that we got, growth factor is, this is for 0 to 0.5. But we need to know from 0 to 1. So we want to know this B. This B is different. What's this? This is the different B. So how do we find this B? So B is, so from 0 to half, see, there are, if the input increases by 1, so if this is plus 1, right? But in between there are 2 halves, see 1, and there is also another, so there are 2 halves, the 2 increments of half. For one increment, there are 2 halves, half, and another half. So you see? In other words, the growth factor that we got here, 1.5, is only from 0 to here. That means, so this means, but the growth factor that we want is for this piece. See this piece here? So when it is 1, we don't know what is this one. So this is the number. So we want to know what is the growth factor from here to, so from here to here, and then from here to here. So from 200 to 300, and 300 to the next one. So there are 2 of those factors. Which factor? The one that I wrote, B1. See? So this is B1, which is half. B1, again half. So you have to multiply half. How many times? Sorry, not half, which is 1.5, right? I made a mistake here. This is 1.5, 1. So what I'm trying to say is, this B, the growth factor, is for the increment of x from every 1 increment. Inputs are increases by 1. So when 0 to 1, so that's how I write 1. So it is going to be, so this B is B1 times B1x, which is 1.5 times 1.5, and the growth factor now is 2.25. How beautiful? Right. So the question can be, hey, what's the percent increase here? If you see this, we can easily write this as 1 plus 1.25. Of course, this is in addition to really understand the concept. It means this is 100%, plus this is 1.25, 125%. You know why? Multiplying and dividing by 100. So that means the percent increase. This is the percent increase. So percent, what percentage increases? Which is 125%. But that's you're not required. But I'm just saying some of you may be thinking, hey, what is the percent increase? So that's what that means. Okay, so your final answer, what is, so therefore, this was the question, right? We need to know, this was the question, and I am ending it saying y is, in the beginning, it was 200, and then the b that I got is 2.25 raised to the power what?
We don't
The-
know.
Yeah, the x. X could be anything. Now x could be anything. As long as you have this piece is for growth factor for the increment of x is 1, I hope I made little sense. That gives the answer for the left side. And if you see on the right side, they give us more information. So let's see what information is given for this. There is a exponential decay. See this function is, there is an exponential decay here. So y-intercept is, let me copy the question, given to you 100, and y coordinate of b is given to you is 50. These two things are enough for us to finish the problem. Okay, right? So, if y-intercept is 100, can you write down here? This means this 0 is 100. So simple. So that's the A part, the initial value. So when you write the equation, y equals A times b raised to x. Again I repeat, this b is decay factor. Okay, and that is where for increment from 0 to this is from 0 to 1. So this is for x 0 to 1, or it could be 1 to 2, could be 2 to 3, it could be 1.5 to 2.5, it could be 1.75 to 2.75. So there should be always increase of 1. Agree? Agree? Yeah. Now, if you see the second one says y coordinate of b is 50, that means this is 50. So when it is 1/4, think of a situation that there is a cup of water here, and you kept it you boil it, and you know when you boil, it boils at 100 degrees Celsius. Water boils at 100 degrees Celsius. So you boil the water, then bring it out from the okay, just heat it, or maybe you warm it till 100 degrees, and then keep it out and keep it on the table. You want to know what happens in 1 hour, actually. So how the temperature goes on decreasing. And you can see this is like every quarter of an hour, half hour, 3/4 of an hour, how the temperature behaves. And the problem says, hey, in 1/4 the temperature goes down by how much? This. So it's given to you as 50. So this is what is expected, that you're showing, you're labeling, you're writing the coordinates, a few things to make sense out of the problem. Nobody's saying that. Agree? Okay, so now the C, they already gave us C also, which is, if you see this, in 3/4, this answer is given to you, 3/4 is 12.5. Different ways to do, but I'm going to use this 100 to 50 is more easy. We all know what happened in 15 minutes, quarter of an hour. Okay, so the cup of water boiling 100 degrees. See, this means that the water was boiling at 100 degrees in the beginning, and then you keep it outside. And then what happens is every 15 minutes, the temperature becomes half. You see? So, so in this example, this is that, right? So let's write down. A is in initial value which is 100. So he's already A. Are you happy? A is 100 degree. Here this 100, it does not tell you anything about in real life. I'm just trying to connect that as if like, oh, it's 100 degrees Celsius and then the temperature going on decreasing. And within a quarter, so this means in 1 quarter means this is like 15 minutes, this is 1/4, right? So in 1 quarter, how much is what's the decay factor? So that's what I'm asking. What is this? What number multiplies 100 to get to 50? So our goal is to find this B is what, right? This we want to know what is B, but to know this, that's for every increment of 1. But can we at least find some decay factor for smaller ones? Can you see from here? So from 100 to 50, let's call this as B1, small, which is decay factor. So this is what? Decay factor for increment of input or the x by 1/4. So when every time 1/4 it is
For what?
of input by 1/4, which means every 15 minutes. That's what it means. See, so every quarter of an hour, the temperature falls half. So 50% goes, 50% stays, kind of. But because this is a common sense, it's easy to do. B1 is 50, this is 50, and the other one is 100, and we all know it is half. So B1 is half. Which is 0.5. 50%, right? So 50% retains, stays. So every 15 minutes, the temperature is lost about 50%, and so that's B1 is. But then we need to know what is B. This B is the question mark. In an hour, how many quarters are there? 4 quarters. So that means this is another quarter. See, this is another quarter. This is 1. That's important. And this is another quarter. There are 4 increments of quarters. If there are 4 increments of quarters, that means this initially you're multiplying by half. See that half? Then again, now there's one more here which I missed here. So this means from here to here will be multiply another half. From here to here we multiply by another half. And so this is 1, so this will be another point, see this? So there will be another coordinates here. So from 100, then it is 50. Common sense tells us 50 will become 25 here. See, this will be 25. So half of 50 is 25, and half of 25 is 12.5, and half of one more half. See, we have to multiply another half, which is 6.25. Do you agree with how beautiful it is? So that means how many halves do you do this? 1, 2, 3, and 4. So the value, the B, the question was B, right? So this is like B is B1 times B1 times B1 times B1, which you're multiplying the half 4 times. Correct? Okay? And then that B is 1/16. Now if you use the calculator, Diego, just tell me what is 1/16 on your
Looks 1/16.
Yeah, just 1/16. Use the calculator and just tell me. Now if you calculate is 1/60, we want to know what percentage retains, stays, or what percent?
0.0625.
So if you see this is 0.625, correct?
No, 0.0625.
Okay. Why you are yelling at me? Okay, anyway, 0.0625. What this basically means, of course, this is what we are going to take. I'm going a little beyond so that you really understand what's happening here is, this is, if you multiply by 100 and multiply 100 and divide by 100, this is 6.25 over 100, which is 6.25%. So it means from the beginning, 100, in 1 hour, only 6.25% stays. Then how much is lost? Look at it. So how much so this percentage decay, this is called percent decay. This is how much percent decays. Or you say how much, so this percentage that it shows is, so what percent retains. So percent decrease is different. Percent decrease, so watch this. Percent decrease is 100% minus 6.25%. And if you do that workout, I think it is 93.75%. I think 94, 6 to 7, yeah, 93.75. Yes or no? So that means when the water boils, you keep it outside, in 1 hour, 93.75% is lost, and how much stays? 6.25% stays or retains. So that's the understanding of this. But our final conclusion, of course, you don't have to write this. This is for some students who really want to go deeper into mathematics. It helps to really make sense out of it, what's happening there. But here our answer is y is 100, that's the A, and the B is 1 over 16 and raised to x. And then x can be anything. I hope I made sense for this nice example to now. Let's do the last part. Go to the next page. Go to the next page. I hope I made sense. Okay, so if you see, go to the where is it? So the first question is asking why those two equations are same. This one? Okay. Okay, this one. Okay, this part, right? So this side it says option. Should not take much. Everybody right? Quickly I'll finish. So now the first question is, watch. There's a bacteria population and it starts at 1,000 in the beginning. Initially, there is a bacteria population. This is biologists are working on research, working on number of bacteria growing. Okay. So, why? Watch this back. Now I want you to make a quick table. Everybody make a table so that we really understand what's going on. So that means there are. So this is the maybe T. I'll write T, and here I'll write down the bacteria. Okay. So T is and every one. So this is like one. Now what is one stands for? This one when t is 1, basically means 10 hours. So every group of 10 hours is t, 1. So when I talk about what does that t equals 1? What is t equals 1 means? Means there are 10 hours. If I say t equals to how many hours? Yeah, it's just to make group of, so every group of 10 hours is like a increment of 1. Make sense? So if t is 2, it's a group of 2 groups of 10 hours. What does this means? 2 groups of 10 hours. That means how many hours? 20 hours. If t is 3, what is the meaning of this? 30 hours. Now the question is, in the beginning it was 1000, and in a group of 10 hours, it turns out to be double, so it becomes 2000. So what happens in this case is, from 2000, the population, the growth factor, here the growth factor is 2 times. So 2 times 1000 is 2000. So this is the beginning, and in between, many of you wonder why did I leave the space there. So you can see this is like 1, 2, 3, 4, 5, 6, 7, 8. So this is like, I'm just keeping it blank to show from here to here you are talking about a group 10 hours, but the question is, why is this 2 same? What's the fun? If I multiply this h, what do you get?
H.
No, h times 1/10.
Oh.
So 1/10 of an h, what is this answer? Is it not
H
h
over
by
10.
Is it not the same thing? Yes or no? So they are the same thing. Because when you multiply h to 1, it is h over 10. So it's the same thing. So how it is different is, so this growth factor is, the b is 2, but if I want to know, the next question is, by what factor does the bacteria population grow each hour? That means, let's see, this is h equals 1, this is h equals 2, h equals 3, h equals 4, like that. If you think of only hours, then what is the factor? Is the question. So it means every time there are 10 increments, so it is one increment will be from here to here will be 2 raised to 110. So it means there are 10 of them. What is this? This is confusing. So it means there is a B1, 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 B1. There are 10 of this, which gives you 2. Because from 0 to 1, the factor is 2. But in 0 to 1, there are 10 different smaller pieces. So 10 of these pieces, like you see, 10 of this gives you 2. And if you use your radical formula, taking 110, this is B1 is 2 raised to 110. So the growth factor, this is the growth factor for each hour. Growth factor for each hour. And that's all you're supposed to write. And I'm ending this. Make sure, okay. So thank you very much. You can stop.